New equation. How do you calculate that one? Okay, so if you call this delta G1 and you call this delta G2, how is delta G3 related to delta G1 and 2? Yeah, so this is going to be equal to delta G1 times plus. So what do you think? Yeah, turn it as plus. Delta G2. Now, if you're looking at KEQ, then it's, if you look at K1 and K2, then for K3, K3 is equal to K1 times K2. So if you add equations 2 and equations 3 together, note that we have minus 7.3 plus 3.3. So note that delta G for that new equation is going to be greater than 0 or less than 0. Less than 0. So that makes that reaction pretty spontaneous.
What about part G of that question?
See, part G, see your answer for work in part E. So for part E, for reaction 4, which you add these reactions 2 and 3 together, you want to determine the sign for Q, W, delta H, delta S, and delta E. Give reason for your answers. So you have to do that part E before doing part G. So let's see. Okay, well, let's do that part. So let's add these two together. Well, maybe rather than doing the, how would you answer that question for part E? But how would you calculate W and Q first before you calculate delta E?
Yes, it's law.
Now see, all you have to do is figure out the sign, whether it's greater than 0, less than 0, or equal to 0. You actually don't have to calculate a numerical value. You can if you want to, but remember that delta H, delta S, and delta E, these are thermodynamic quantities which cannot be directly measured. Q and W are not thermodynamic quantities which can be directly measured. We can calculate delta H, delta S, and delta E by relating to Q and W. For example, for how do we figure out work for the sum of these two reactions? What do we need to look at? We need to look at what state of matter? The gases. Are there any gases involved in reactions 2 and 3? No. So what can we say about work for the sum of those reactions? Yeah, work has to equal 0 then. So if work equals 0, if we go to part G, see your answer for work for part E. Is it important for this reaction to produce work or have work supplied to it? Give reasons. So how do you answer that question? So if we said that work is 0 from part E, is it important that this reaction produce work? So could you use that reaction to run a heat engine or a refrigerator, or would you want to? If it doesn't produce work. Yeah, so for a heat engine, remember that we're converting heat to work, so if that reaction isn't producing work, then it's not going to be useful in a heat engine. Let's see, what other ones we have? Here's one on, we talked about this one right before spring break, that swimming pool. So this is a swimming pool one here. There are a few reactions involved with that one. So let's see. If you take a look at this one here, let's see. Okay, so there's 4 reactions here. There's different types of reactions. So for example, could you determine the products of reaction 4, HOCl, producing 2 products? So how would you answer that question? So what type of compound is HOCl? Yeah, so if it's an acid, that means what do acids do? Yeah, so donates a proton and what else? Yeah. And how would you answer this? In other words, for reaction 4, this would be the acid dissociation equation. Then what about reaction 3? So OCl minus, if HOCl is an acid, OCl minus is a base, and then what's the name of, what is it, what type of reaction is this one when you have a base reacting with water? That's that base hydrolysis reaction. And then for the equilibrium constant, what's this equilibrium constant called for reaction 3? Yeah, KB, and for reaction 4, that's KA, so here's that one. So we did reaction, we did this problem 2 in class. Was this on your last one? Fuel, so how would you calculate, so for this one here, for each fuel to determine whether delta H, delta G, delta S or work is greater than 0, less than or equal to 0, so for example for ethanol, is delta H going to be greater than 0, less than or equal to 0? Okay, so for example, here's a comparison of fuel. So how would you calculate? So for this one here, for each fuel to determine whether delta H, delta G, delta S or work is greater than 0, less than or equal to 0. So for example, for ethanol, is delta H going to be greater than 0, less than or equal to 0? So if it works as a fuel, delta H has to be, it has to be less than 0 because we know that fuels have greater than 0, less than 0. Yeah, greater than 0. And what if you have gases involved? Is that going to increase the entropy or decrease the entropy? It decrease the entropy. And then for K, yeah, less than 0. How about delta S? How can we figure out delta S? We want to look at the, see, one way to figure out delta S is look at the number of reactants, number of moles of reactants versus number of moles of products. Okay, so if there's more products than reactants, chances are delta S is going to be greater than 0, less than 0. Yeah, greater than 0. And what if you have gases involved? Is that going to increase the entropy or decrease the entropy? It decrease the entropy. And then for K, how would, if you know delta, if you know one of these quantities, how can you figure out K, the equilibrium constant? You relate to delta G, so if delta G is less than 0, that means K has to be greater than 1 or less than 1. Greater than 1. Then for work, we figure out how to do it. Okay, so good luck in your final exams. Good luck in the rest of your academic career. I don't see you after the final exam, and I'm hoping that you'll transfer and get your degree and be a successful professional scientist or engineer or health professional.